In this video, I'm going to present you a popular puzzle which is popularly called as Monty Hall problem. Monty Hall was the host of a game show called Let's Make a Deal, on which this puzzle is based. Puzzle states that you are on a game show and you are given the choice of 3 doors. You get to pick one door, and if you have picked the right door, you win the prize. Behind one door is a car, behind the others goats. You pick a door, say number 1. After you have chosen a door, the game show host will not immediately open that particular door. The host will open another door that you did not pick and which he knows does not contain the prize. Assume the host opens another door, say number 3, which has a goat. He then says to you, do you want to pick door number 2? At this point, you will be given a choice. Do you want to stick with your original choice, door 1 in the example here? Or do you want to choose the other unopened door, door 2 in this example? Is it to your advantage to switch your choice? Will you switch or stay with your door? This is an excellent puzzle. Think over it for some time and share your answer in the comment section. Once done, keep watching the video for the right solution. So let me explain the solution now. Here there are 3 doors. You are asked to choose one door among 3 doors, and the host, who knows what's behind the doors, opens another door, which has a goat. After this, you are asked, will you switch or stay with your door? Let us analyze what are the possibilities if you choose to switch the door instead of staying back original decision. Suppose you always choose door 1. Then host will open door 2 or door 3 behind which car is not there. There are 3 possibilities. In the first possibility, if the car is behind the door 1, then host will open the door 2 or door 3, and if you switch to remaining door 3 or door 2, you will find goat behind it and you will lose. And in the second possibility, if the car is behind the door 2, then host will be forced to open door 3. Now if you switch your choice to door 2 from door 1, then you will win the car behind the door. In the third possibility, if the car is behind the door 3, then host has to open the door 2 behind which goat is there. And now if you switch your selection from door 1 to door 3, then you will be winning the car. So out of 3 possibilities, in 2 you will be winning the game show if you switch your choice. The probability of winning the game show is 2 over 3. And if you stay with your first choice, then probability of having car behind selected door is 1 over 3. So to conclude, there is a 1/3 chance of the car being behind door number 1 and a 2/3 chance that the car isn't behind door number 1. After Monty Hall opens door number 2 to reveal a goat, there is still a 1/3 chance that the car is behind door number 1 and a 2/3 chance that the car isn't behind door number 1. A 2/3 chance that the car isn't behind door number 1 is a 2/3 chance that the car is behind door number 3. So it's better to switch the choice as it increases the probability of winning the game show from 1/3 to 2/3. So does this logic applies for any number of doors? Let's analyze. Imagine that instead of 3 doors, there are 100. All of them have goats except one, which has the car. You choose a door, say door number 23. At this point, Monty Hall opens all of the other doors except one and gives you the offer to switch to the other door. Would you switch? Now you may arrogantly think, well, maybe I actually picked the correct door on my first guess. But what's the probability that happened? It is 1 over 100. So there is a 99% chance that the car isn't behind the door that you picked. And if it's not behind the door that you picked, it must be behind the last door that Monty left for you. In other words, Monty has helped you by leaving one door for you to switch to that has a 99% chance of having the car behind it. So in this case, if you were to switch, you would have a 99% chance of winning the car. Hence, here also it is better to switch to choice as it increases the probability of winning the game show. These kind of problems requires a proper logical thinking to get into the correct solution. Hope you enjoyed this video. Thanks for watching. Let's meet in the next video with one more interesting puzzle. Thank you.